In this tutorial, I will demonstrate how to restore the IOTA seed using the Ledger Nano S recovery phrase. The purpose of a Ledger Nano S device is that seeds and private keys never leaves the device. Restoring the IOTA seed from the recovery seed does in fact the opposite and is therefore not recommended. If you do restore the IOTA seed from the recovery seed, your recovery phrase and IOTA seed gets exposed outside the Ledger device and you create a security risk. Your recovery phrase and or extracted seed may get stolen and thus all your IOTA funds. In this tutorial, I will demonstrate two methods to recover an IOTA seed from a Ledger Nano S recovery phrase. The first method is a Python application created by the developer Moxer. See this GitHub page. The second method is a web application created by Mobilefish, that's me, and it is based on the work created by Moxer. See this GitHub page. Use both applications at your own risk. The Moxer Python application uses the following libraries. See this file. Use this link to get more information about these Python libraries. The first Python library is called Mnemonic. It's an implementation of Bitcoin BIP39. More information, see this GitHub page. The second Python library is called BIP32utils. It provides a small set of utilities for generating Bitcoin hierarchical deterministic wallet addresses using BIP32. More information, see this GitHub page. As you can see, Moxer has also created this library. And the third Python library is called IOTA. It is the IOTA Python API library. More information, see this GitHub page. This is Moxer Recover IOTA Seed from Ledger Mnemonic's project. Please read the warning. Never give your seed or recovery phrase to anyone. They will steal all your cryptocurrency token or money. We will never ask you for this information. Here's a step-by-step guide. You can either install the requirements on your own, which I have done, or use the following scripts if you are on Ubuntu, these scripts. I will demonstrate these steps. First, download this project. Click this button. Select Download zip file. Once the zip file is downloaded, unpack the zip file. The zip file is unpacked, as you can see over here. Please note, I am working on a Mac operating system and I have already installed Python and the virtual environment tool. First, create a new virtual environment inside this directory. Enter this command and press Enter. Activate this environment. Enter this command and press Enter. Now install the required libraries by entering this command and press Enter. Let's execute this Python script. Enter this command and press Enter. Now you can enter your recovery phrase. In IOTA tutorial 31, this was my Ledger Nano S recovery sheet with these 24 words. I will enter these words in the Python application. You can now enter your Ledger Nano S passphrase if you have set it. This is not your PIN number. I have not demonstrated how to use the passphrase with the Ledger Nano S, but if you have set the passphrase, you can enter your passphrase here. In IOTA tutorial 31, I have not used a passphrase, so I will press the Enter key. And as you can see, this is my seed. I have copied and pasted the seed in this text file. As you may notice, this application does not ask for the Ledger account index. By default, this Python application sets the Ledger account index to 0. As you can see, there's also a Python script called create addresses from seed. Let's execute this script. Enter this command and press enter. I have entered the previous generated seed. It asks for the address start index. Let's start with address index 0. And the amount of addresses I want to generate is 5. I have copied the generated 5 addresses and pasted the 5 addresses in this text file. As you can see, address 0 and address 1 matches the address generated by Maxer's tool. Please note, the last 9 characters are checksums, which does not appear in these generated addresses. This is the second method. The Mobilefish web application uses the following JavaScript libraries. The first JavaScript library is JSBIB39. It is an implementation of Bitcoin BIP39. The Python mnemonic library has been ported to JavaScript and is called JSBIB39. More information, see this GitHub page. I have used this version. This library works in a browser and does not need to be browserified. The second JavaScript library is BIP32 utils. It provides a small set of utilities for use with BIP32 hierarchical deterministic key nodes. More information, see this GitHub page. I have used version 0.11.1. It is a Node.js module. How this module is browserified is explained in this tutorial. The third JavaScript library is iota.lib.js. It is the IOTA JavaScript library. I am not using the new iota.js TypeScript port of iota.lib.js. More information about this library can be found at this location. I have used version 0.5.0. This library works in a browser and does not need to be browserified. The last JavaScript library is called curl, a hashing function based on ketchup with conversion to ternary. More information, see this GitHub page. I have used this version. It is a Node.js module. How this module is browserified is explained in this tutorial. Go to my GitHub page and select Ledger Recovery Words to IOTA seed. Please read the warning. The code is not reviewed and tested by independent parties. This means this code is not safe. If you enter your personal recovery words in this application, you risk your recovery words to be stolen. If anyone has your recovery words or seed, they can steal all your IOTAs. This application also generates addresses. Do not use these generated addresses to receive funds. If you do, these addresses may be reused for outgoing transactions, which means IOTAs on these addresses can be stolen. Use this application at your own risk. You can also find this application online, but please do not enter your personal recovery words in this application. Only enter dummy or test recovery words. It is created for educational purpose only. Click on this link. Do not enter your personal recovery words. If you do, you will lose all your IOTAs. I will now demonstrate how to install and use this web application. First, download this project. Click this button and select Download Zip. You can now close this browser. Here is the downloaded file. Unzip this file and open this HTML file with your favorite browser. And this is the web application. In this field, you enter your 24 mnemonic words. In this field, you can enter your Ledger Nano S passphrase if you have set it. This application allows you to enter your Ledger account index. Here you enter your address start index and the amount of addresses you want to generate. This is my Ledger Nano S recovery sheet from IOTA tutorial 31. I will enter my 24 recovery words in this field. I have entered my 24 recovery words in the correct order and separate each word by one or more spaces. Please note, all words will be automatically converted to lowercase. I will leave this field empty because I have not set a Ledger Nano S passphrase. In IOTA tutorial 31, I have used ledger account index 0, so I will keep this value. And I'm interested in the 5 first addresses. Address start index, it will be 0, and the amount of addresses will be 5. Let's assume I make a spelling mistake. I remove the C from Arctic, and I remove the H from rhythm. So I've made 2 spelling mistakes. If you only want to convert words to IOTA seed, press this button. If you want to convert words to seed and also generate IOTA addresses, press this button. Let's click this button. As you can see, the words Arctic and rhythm cannot be found in the BIP39 words list. So this word and this word cannot be found. You can use this English word list to check the correct spelling. So let's fix these 2 spelling mistakes. Press this button, convert words to IOTA seed. And here you can see the restored IOTA seed. I also calculate the seed checksum, the seed length, and I also display the path, which I will explain later. If you want the seed and addresses, press this button. And here are the generated addresses. As you can see, I also include the 9 characters checksum at the end. I will copy this seed and addresses in this file. As you can see, Maxer seed and addresses are the same as Mobilefish seed and addresses. Refresh this screen and enter the 24 recovery words again. Enter a different ledger account index, for example 1. Address start index is 0 and amount of addresses to generate is 3. Press this button. And as you can clearly see, the seed does not match and the first 3 addresses also does not match. Which means if you use a different ledger account index, it will generate a different IOTA seed. I have entered value 1. This value 1 matches this value. If you enter value 5, press this button. As you can see, the 5 appears here. This number 5 represents the ledger account index. In the following slides, a technical explanation will be given how the IOTA seed is restored from the Ledger Nano S recovery phrase. I assume you know what BIP32, BIP39 and BIP44 are. If not, please watch these 2 blockchain tutorials which I have created. Blockchain tutorial 28, which explains Bitcoin Improvement Proposal 39 mnemonic words. This YouTube video. And blockchain tutorial 29, which explains hierarchical deterministic wallet BIP32 and BIP44. This YouTube video. Based on this code, which is my web application, I will explain how it all works. The recovery phrase and optional password, which is a salt, are used as input for the password-based key derivation function 2, which outputs a 512-bit seed. As you can see, the password-based key derivation function 2 uses the passphrase and the recovery words as input, and it outputs a 512-bit seed. And this is how it is coded. The next step is to create a master node. As you can see, to create a master node, it needs the master seed. And this is how it is coded. The master seed is used as input to create the master node. Again, the password-based key derivation function requires the recovery phrase and optional password as input to generate a master seed, and a master seed is used to generate the master node. The letter M denotes the master node. The IOTA Trinity wallet implements BIP44 to generate accounts and addresses. BIP44 defines a standard method for deriving many keys for different users from a single mnemonic seed in an organized way. BIP44 uses the following derivation path: m/purpose prime / coin type prime / account prime / change prime. The purpose is 44 prime, referring to BIP44. The coin type is 4218 prime, which refers to IOTA, and 0 prime refers to Bitcoin. The registered coin types can be found at this location. Index 0 refers to Bitcoin. Index number 4218 refers to IOTA. The apostrophe, these, indicates hardened derivation. Each square represents a node. This is level 0. The next level is level 1, which represents the purpose. If the purpose is BIP44, then this is the path. If you use BIP49, the path will be this. This is the next level, level 2, and this level represents the coin type. If you use Bitcoin, the path will be this. And if you use IOTA, the path will be this. In this web page, you will find this IOTA hex value. That is this hex value. This constant value is a hardened value, which means this hex value consists of this hex value plus this hex value. So 4218 prime is the same as this hex value, which means this hex value plus this hex value. 4218 prime is 2 to the power of 31, which is the same as this hex value, and 4218, which is this hex value. If this is our derivation path, this is our Ledger account index. In the Trinity wallet, you can select your Ledger account index. And the change level is 0 prime, because the addresses are meant to be visible outside the wallet. So change is always 0 prime. We start with our master node. Our purpose is 44 prime. Our coin type is 4218 prime. And depending on what Ledger account index we choose, we can have 0 prime, 1 prime, etc. In tutorial 31, I have chosen Ledger account index 0, as you can see over here. Then this value will be 0 prime, and the change will always be 0 prime. That's this value. So level 0 is the master node, level 1 is the purpose level, level 2 is the coin type, level 3 is the account level, and level 4 is the change level. The IOTA wallet uses the following derivation path: m/44 prime / 4218 prime / the Ledger account index you have chosen prime / 0 prime. This is how it looks in code. Don't forget these apostrophes. And if we have the path, we can create our node. Each node contains 3 pieces of information: a private key, a public key, and a chain code. The chain code is to prevent someone from determining the children of a node using only the node's public and private keys. And this is the chain code I am referring to. This presentation is from Blockchain Tutorial 29. This node is our change node with this derivation path, and each node contains 3 pieces of information: the private key, the public key, and a chain code. The private key and the public key together forms the key pair. The next step is to get the node chain code. This is how it is done in code. The next step is to get the node key pair. This is how it is done in code. The next step is to extract the private key from the key pair. This is how it is done in code. So the private key is this value. This output can be generated if you set the debug variable to true in my web application. The next step is to create a new byte array called data bytes. The data bytes array consists of the first 32 bytes of the private key, followed by the first 16 bytes of the chain code, followed by the last 16 bytes of the private key, followed by the first 32 bytes of the chain code. The data bytes array contains in total 96 bytes. This is how it is done in code. And here is the rest of the code. The next step is to create a curl instance. This is how it is done in code. Next is to convert the data bytes, which consists of 96 bytes, to a Crypto.js compatible word array. Each word consists of 32 bits. A word array is an array consisting of 24 words, which means 24 times 32 bits is 768 bits. And this is how it is done in code. Here is an example of a word array. This represents one word, 32 bits, and here is the next word. Next is to create a Crypto.js word array object. More information about Crypto.js, see IOTA tutorial 21. And this is how it is done in code. Curl.k object executes this Crypto.js method, which creates a SHA-3 instance. Curl.k update reads in the Crypto.js word array object that will be SHA-3 hashed. Please note the Crypto.js SHA-3 algorithm implemented catchuck and not SHA-3. This is how it is done in code. And the final step is to create the IOTA seed. And this is how it is done in code. With the IOTA seed, the addresses can be calculated. More information how addresses are calculated, see IOTA tutorial 9.1. So once we have calculated our seed, we can generate our addresses. And this is important to know. For each different ledger account index, 0, 1, etc., you will have a different seed, which means you will have different addresses. As you can see, I can choose any ledger account index number. If you select a ledger account index, always make sure to write down your chosen index number. So don't forget, always write down your ledger account index. Thanks for watching. I hope you enjoyed the video. Please hit the like button and don't forget to subscribe. If you have questions, leave your comments below. I'll do my best to answer them.